Hey guys, we are doing the notes today for Chapter 7, Section 9. This ought to be the shortest one ever. Let's just do it. It will be quick, I promise. So all we're adding today is we're trying to add 4 new definitions for you, or theorems, so that you can use them to do proofs. And the first one is the definition of a midpoint. And as you see, I like to write all definitions and theorems as if-then statements. So the definition of a midpoint is, if a point is a midpoint, then it divides a segment into 2 congruent segments. So, for instance, I showed you how to use it in a proof here. It says B is the midpoint. So this point is the midpoint. And if I knew it was the midpoint, then I would know that this length is equal to this length, or congruent to this length, by the definition of a midpoint. You can see why that might be important. If you had, say, 2 triangles that look like this, and you knew that that was the midpoint of the bottom, then you could say that this segment equals this segment, and you'd be on your way to proving that the 2 triangles are congruent. All right? All right, so that's the first one. Second one is the definition of an angle bisector. This one says, if a ray, or maybe a line or a segment, is an angle bisector, then it divides the angle into 2, I wish I had put congruent there, congruent angles. So that is saying that if I know that this ray is a bisector, so I just bisected the whole angle, then I know that this angle is equal to this angle, or congruent to this angle, right? I should always use the word congruent when talking about angles. And again, you can see how that might be handy. If you had these 2 triangles, and this angle up here got bisected, then you would know that this angle was congruent to this angle, and that might help you prove that the 2 triangles are congruent to each other. All right, that brings us to number 3. 3 and 4 are basically the same thing. The isosceles triangle theorem. I don't know if you know, but an isosceles triangle is a triangle with 2 equal sides, 2 equal side lengths, right? Do you guys know what a triangle is called that has no equal side lengths? That is called a scalene triangle. And do you know what a triangle is called that has 3 equal side lengths? That, of course, is called an equilateral triangle. But we are dealing with the isosceles triangle. That is a triangle with 2 equal sides. Technically, at least 2 equal sides. So this basically says, I really like this right here. It says if the 2 sides are equal, then the angles opposite those sides are equal. If the sides are equal, then the opposite angles are congruent, right? And so I have written that in the proof form here. In this triangle, I know that this side equals or is congruent to this side. And by the isosceles triangle theorem, therefore I know that this angle is congruent to this angle. And again, that might be helpful in proving something at some point. And then I had the converse of this. It's the same rule, just the converse. And basically the converse, we just switch the if and the then. So this one says, if the angles are congruent, then the sides would be congruent. And this would be a perfectly fine thing to put instead of writing out the name of the theorem. You could just put this, therefore this, right? And that means the same thing as the converse of the isosceles triangle theorem. That's it for today. Under 5 minutes. We are going to use these next week. Thank you for watching.